Okay, for question number 39, which is the last question of this set, we have to consider the following electrical circuit diagram. It has identical resistors of 3 ohms each that are connected as shown in the figure. So these two are in parallel, these three are in parallel, these four are in parallel. Now, if the reading of the ammeter is A1 is 1 ampere, so here the reading is 1 ampere. We have to answer the following questions. Okay, so what is the relationship between the readings of A1 and A3? So let's say if the current here the current is 1 ampere, so when the current passes through these three, here it will come as 1 ampere total current. Now the current is distributed equally in these three, and it comes out to be 1 ampere here is distributed equally in all these four, and it comes out to be 1 ampere here. Okay, so that means A3 and A1, it has the same readings of 1 ampere, and reason is that they are connected in series. So for first one, A1 is equal to A3 is equal to 1 ampere, as they are the ammeters connected in series. As these are the ammeters, they are connected in series. Okay, the first one is done. What is the relationship between the readings of A2 and A3? So this is A2 and this is okay here, because these are the identical resistance, so the current is equally distributed here in all the three. So these are four. So here the each of them will have 1/4 of the current. So 1/4. So each of them will have 1/4, 1/4 ampere of current. So this is 1/4 ampere here, 1/4 ampere here, 1/4 ampere in this one, and 1/4 ampere in all each of the four resistors because they are identical. So the total current going in for these was 1 ampere, and 1/4 is distributed equally here. So that means this will give us the reading of the 1/4 ampere of current. And here the current will combine 1/4, 1/4, 1/4 will combine, and it will come out to be 1 ampere here. So the readings of A2 and A3, what will the readings of A2 and A3? So in current, A2 will have 1/4 of the reading of A1 because it has 1/4 current. So, sorry, A3. So A2 will have 1/4 the reading of A3. Now determine the reading of voltmeter V1. Where is voltmeter V1? So V1 is considered here across these two resistances. So so for C, and this is for, we are going for voltmeter V1. So volts for voltmeter V1. So these are resistances connected in parallel. So resistance here will be Rp. That is 1 by Rp is equal to 1 by 1 3 plus 1 by 3 plus 1 by 3, which is equal to 2 by 3. So that means this is 1 by reciprocal of the resistance in parallel. So Rp is 3 by 2 ohm. And we have to find the reading of voltmeter V1. So that means we have to find the potential difference here. So we have Rp and current here. The current will be distributed equally. It's coming out to be 1 ampere. So 1 ampere current is going to both these. So for both these, because we have treated this as a combination, so 1 ampere current will be going in both these, and we know that V is equal to IR. So here the reading of the voltmeter V1 is equal to I is 1A, and this is 1 ampere. So resistance is that is equal to 1.5. The reading of this voltmeter V1 will be 1.5. So we have got the reading of 1.5 volt for voltmeter V1, which is connected in parallel across these two identical resistors, 3 ohm and 3 ohm. Okay, moving on to the OR part, we have to find the total resistance of the circuit. Okay, to get the total resistance of the circuit, okay, let's get the resistance for this part now. So these two are connected in parallel. So its resistance will be 1 upon Rp. Let's say it's R1. Resistance is R1 for these two resistors. Okay, so I'm considering the total resistance for this circuit is R1. So 1 upon R1 is equal to 1 upon R3 plus 1 upon R3, which is 2 by 3. ohm and R1 is now 3 by 2 ohm. Okay, let's consider the resistance for this as R2. Okay, so which are also connected in parallel. So 1 upon R2 is equal to 1 by 3 plus 1 by 3 plus 1 by 3, which is equal to 3 by 3, which is equal to 1 ohm. So that means R2 is equal to 1 ohm. So the net resistance of these three is 1 ohm. This has come out to be 3 by 2 ohm, and these are four identical resistors connected in parallel. So net resistance of these four would be, let me consider this as R3. So 1 upon R3 is equal to 1 upon 3 plus 1 upon 3 plus 1 upon plus 1 upon 3, which is 4 by 3 ohm. But this is not the resistance R3. R3 should be the reciprocal of this. This is 3 by 4 ohm. Okay, now these, we have our circuit like this now. So this is R1, this is R2, this is R1, this is R2, and this is R3. So R1 is 3 by 2. So this is 3 by 2 ohm, and R2 is 1 ohm, and R3 is 3 by 4 ohm. Now all these are connected in series. So let's find out the total resistance of the circuit will be the sum of R1 plus R2 plus R3, as they are in series now. So this is 3 by 2 plus 1 plus 3 by 4, and LCM here is 4. So this is 6 plus 4 plus 3, which is 6 plus 4 is 10. This is 13 by 4 ohm. So 13 by 4 ohms means it's 4 threes are 12, 2 and 5. So 3.25 ohm is the total resistance of the circuit. Okay, so with this we are finished with this set. Do like, share and subscribe. Thank you for watching.